All right, guys, 13C. So hopefully yesterday we don't feel too overwhelmed. Today I would probably just dedicate this lesson to 13C, which is a short exercise, and it is reasonably straightforward. So that will allow us to catch up on the parts of A and B that we might have missed. It means I can do a lot of deliberate instructive teaching to you guys one-on-one if you have questions about it. So these are the laws of logarithms. Okay, we're just going to leap straight into the applications of them. And what we have is that we often have like two logarithms together and we want to group them. We want to simplify it, right? So if we're adding the logarithms, if we have log A plus log B or log n plus log n, it's going to be log n times n. So this one here, this is going to simplify to log of 2 times 10. And we know our 2 and our 10 times tables. We know that's log of 20. Okay? And you can verify something like that in your calculator. Put log of 2 in, put log of 10 in. What does it simplify to? Log of 20. What does log of 20 mean? Alright, if you evaluate it, you get like 1.3 or something like that. It means 10 to the power of 1.3 equals 20. Okay, onto this one. When we have a subtraction, it's the top one divided by the second one. So we're going to have log of 120 on 6. And 120 divided by 6 is 20. So log of 20 again. So both of these, log 2 plus log 10, it's equal to log of 120 take log of 6. Alright, on to C. Now C is only a little bit different in that I've introduced a different base. So we can only collect them if they have the same base, right? Both of these are base 3, the logarithm in base 3, so we can collect them. That's going to be the logarithm in base 3 of 28 on 4, which is the logarithm in base 3 of 7. 28 divided by 4 is 7. Okay, here it will say something like, write this as a single logarithm. And so we've got one logarithm, but we've just got a number, so we can't collect it. We need to express this number 3 as a logarithm in base 2. So the way we'll do that, this part stays the same. This part is the log in base 2 of 2 to the power of 3. So we're engineering backwards there. This would simplify to 3. We've expressed it as a single power of 2. The base is 2. We've expressed it as a single power of 2. So it simplifies to the 3. We're going back the other way. We're starting with 3 and we need to write it as a logarithm in base 2. Alright, so all we do, we take that 3, log in base 2 of 2 to the power of 3. Alright, so they will pop up. They're a bit tricky. If you find that tricky, let me know. Log in base 2 of 8, 2 to the power of 3 is 8. And now we can collect them, right? They're both logarithms in base 2. So that's going to be the logarithm in base 2 of 5 times 8. And 5 times 8 is 40. Okay. On to E. We've got 3 lots. That means 3 times log 2. And we have 2 times log 3. We want to collect them together, write it as a single logarithm. So we're going to use this last law here, which says if there's a number out front, you can make that the power of the value of n. So we can express this as log of 2 to the power of 3. Alright, we can move that up to become the power here. And we'll do the same for the second term. So that's going to be log of 3 to the power of 2. We'll simplify both of those. 2 to the power of 3, that's a log of 8. And 3 to the power of 2, that's log of 9. Okay, so just following the equality here, 3 lots of log 2 is equal to log 8. Different way of expressing it. 2 lots of log 3 is equal to log 9. Now, we can collect them, right? That's going to be log of 8 times 9, which is log of 72. Okay. we've got two more. I'm just going to clear the space here. We have, guys, logging base 3 of 9 on top of logging base 3 of 81. So what we're going to do is express these. We just have to simplify it as best as we can. So logging base 3 of 9, we can express that as logging base 3 of 3 squared. Okay, 9 is the same as 3 squared. And at the bottom, we can have logging base 3 of 81 is 3 to the power of 4. Now, from this step, there's two possible paths we can take. And I'm going to show you both, right? Because we're trying to draw out those log laws. The first one is just with log simplification, right? If I have logging base 3 of 3 to the power of 2, that's just going to simplify to 2. We've expressed the top here as a single power of 3. So the top simplifies to 2, and the bottom is going to simplify to 4. So it simplifies to 2 and 4, which is half. Okay? That being the simplest way to write it. The other way to think about it is if we're using log laws right, these powers can come out the front, can't we? So we could express what we have here, we could express that as 2 logging base 3 of 3 on top of 4, bring that power out the front, 4 logging base 3 of 3. All right, we can bring the power out the front. And then when we have the same thing as a product at the top and the bottom, it can cancel. So the logging base 3 of 3 is going to cancel. So we're cancelling that because it's a factor at the top and the bottom. We're left with 2 on 4, which is a half. So two ways of getting to the same thing. I'm drawing out this one to show you that the log laws will simplify in the same way. All right, so that was question 2, and then on to question 3. Now, question 3 says, show that log of 1 on 25 equals minus 2 log 5. Okay, they want us to show this is true. Now, anytime we're given a show that question, we're either going to start with the left-hand side and manipulate it until we get the right-hand side, or we can start with the right-hand side. All we need to do is show that at some stage the left-hand side is equal to the right-hand side. So this is how we communicate it. I'm going to have the left-hand side is equal to log of 1 on 25. Okay? That's what's on the left-hand side of the equation. One way we can express this is that that is log of 1 on 5 squared. Okay? Which is log of 5 to the minus 2, which is minus 2 log 5. Okay, so we're taking the left-hand side and we're just manipulating it. We're expressing it in different ways, and now we've expressed it as the right-hand side. That's what the right-hand side is, minus 2 log 5. So we can do the proof that way, all right? You can start with the right-hand side. You could go, oh, the right-hand side is minus 2 log 5. One way to write that would be log of 5 to the minus 2. One way to write that would be log of 1 on 5 squared, which is log of 1 on 25, which is the left-hand side. Like, it doesn't matter, okay? You can start with the right, you can start with the left. You just have to show that at some stage. You can do both, all right? You just have to show that at some stage they are equal. So that's question 3 there. So that's exercise 13C, all right? So maybe I'd like us to start with that. I think in the first part of this lesson, you don't really need to have done 13A and B to do this exercise. Let's start with this one. Should find the skill okay, and then we can jump back a bit and wrestle with a bit more of A and B. Any questions? All right, let's get into it.
Yes.
Yep.